Today we'll explore the concept of the identity element under a binary operation. An identity element is an element in a set that leaves another element unchanged when combined under a binary operation. In other words, if we have an identity element called E and we combine it with another element A under a binary operation star, then A star E and E star A are both equal to A. Notice that A remains unchanged when combined with the identity element E. For example, consider addition on the set of real numbers. The number 0 acts as the identity element. Why? Because if you add 0 to any number A, you get back the same number A. That is, A plus 0 equals A, and 0 plus A equals A. For example, 4 plus 0 is the same as 0 plus 4, which is equal to 4. That's why 0 is famously called the additive identity. Similarly, in multiplication, the number 1 is the identity element. That's because multiplying any number by 1 leaves the number unchanged. That is, A times 1 equals A, and 1 times A equals A. For example, 4 times 1 is the same as 1 times 4, which is equal to 4. That's why 1 is famously called the multiplicative identity. Here's an interesting problem. The binary operation delta is defined on the set of real numbers such that A delta B equals A plus B plus 5. Determine the identity element E. Recall that A combined with the identity element E should leave A unchanged. So we write A delta E equals A. So in the equation, we substitute E for B and get A plus E plus 5 equals A. Group the A and the 5 on the right-hand side to get E equals negative 5. So negative 5 is the identity element under this operation. Here's another problem. The binary operation star is defined on the set of real numbers such that A star B equals A plus B plus AB. Determine the identity element E. We know that A star E should leave A unchanged. So we write A star E equals A. So in the equation we substitute E for B and get A plus E plus AE equals A. We need to transpose for E, so group the A on the right-hand side and leaves the terms with E on the left. Now factor out E to E bracket 1 plus A equals 0. To solve for E, we divide both sides by 1 plus A. Hence, E equals 0. So 0 is the identity element for this operation. A binary operation star is defined on a set S, with elements 2, 3, and 4 as shown in the table below. Determine the identity element. The identity element is always a unique member in the set, which means that only one of the numbers can be the identity element. Now there are 3 numbers in the set, so we need to check each number one at a time. Now we already know that A star E, or E star A, should give us A. In other words, the identity times a number should not change the value of the number. Let's first check the number 2. 2 star 2 give the same 2. Also, 2 star 3 give the same 3. However, 2 star 4 is 2. Hence, 2 is not the identity number, since it changed the 4 to different number 2. Now let's check the number 3. 3 star 2 is 3, so right away we know that 3 cannot be the identity number, since it changed the value of 2 to a different number 3. And now let's check the number 4. 4 star 2 gives the same 2. 4 star 3 gives the same 3. And also 4 star 4 is 4. Notice when 4 operated on each number in the set, they all remained unchanged. Hence 4 is the identity number. By the way, a quick way to determine the identity number is to simply check the row that's identical to the top row in the table. Looking at the operation table, we see that the number 4 leaves every element unchanged, both across its row and down its column. That means 4 is the identity element for this operation. Pause the video and identify the identity element for the operation represented by this table. The quick way to determine the identity element is to simply check the row that's identical to the top row in the table. Looking at the operation table, we see that the letter B leaves every element unchanged, both across its row and down its column. That means B is the identity element for this operation. By the way, we could have took the long route and check each letter one at a time. You'll see that B leaves each of them unchanged under the binary operation. Thanks for watching. If you found this helpful, don't forget to like, share, and subscribe for more math explorations here on Adobe Math Lab. See you soon.